Hey, what's up, you guys? My name is Vish, and today we'll be trying to solve homework 7 problems. Okay, so the first problem. So we have a data segment, we have an source index, we have AL and AH registers. All right, what's the physical address of the memory location at which the least significant byte will be copied? Okay, so first of all, we have a data segment. Let's assume this is the data segment, and the address of this data segment is this. All right. Then we have a source index. That's this. This means the exact data that we're looking at is located in this at this address inside this data segment. Okay. We have AL and AH register, and the instruction that we're looking at is this. We are moving whatever the content of AX is to the SI. Okay. Awesome. Now, so let's just get some. Okay, so we know that data segment is 1000, and we add another 0. SI is 2222. So to find the exact location where the data is, we'll just add them and find out the address. So there'll be 1222H. So let's say this is that address. I'm gonna use a different color. So let's say this is that address. So this means this will be 12221. This will be 12223, and so on. Right? Cool. Okay. Now let's look at the instruction. So we are moving whatever this is in here. So AX to SI. So we know at this certain point, we are looking at this location in the data segment, right? So, and since each instruction is a 2-byte instruction, this means if the pointer is pointing at this location, this means we'll be taking these 2 blocks in consideration. Let me use a different color so it can stand out. So we're looking at these 2 blocks because the pointer is pointing at the lower, at this address. That's why. Okay, and we know that AX is, goddamn. AX is a 32-bit register, which consists of AH. AX is a 32-bit register which contains AH plus AL. The AH is the higher 16 bits and AL is the lower 16 bits. So in this case, it's asking what's the physical memory location of the least significant byte will be copied to. Least significant. So look at this way. So let's say this is the AX register. It's divided into AH and AL. This will be the most significant bit, and this will be the least significant bit. And how does it go in the memory? So when AX is we are trying to save this AX to this location, but this location is only 16-bit long. So this means the first half of AX, which is AH, will be saved in this location. All right. And the other 16 bits, since this location is only capable of storing 16 bits, the rest of the other 16 bits will be saved in the location right above it. So the least significant bit, or the AL information, will be stored in this section of the memory. So this means the least significant byte will be copied to 122223 at this memory address. Does that make sense? Okay. If it doesn't, that's fine. We're going to do the same problem, but in this case, we'll be looking at the most significant bit. Okay, I'm gonna try to condense this again. So we have the same everything, same instruction. So the first thing we know that AX, it consists of a higher 16 bits and lower 16 bits. Okay, so if this is the AX register, it can be divided into AH, the highest significant 16 bits, and AL, the lower significant bits. So this will be the most significant bits, and this will be the least significant bits. Make sense? Cool. And let's say that's our data segment, and it has this address, and SI is 222H. This means the data segment that we are currently dealing with, to which the pointer is pointing at, will be DS plus SS, which means 10000, and SS is 2222, which becomes 12222. So this address is 12222. Make sense? Let me write it over here. So this address is this, and the lower one will be 12221, and the higher will be 12223. All right. So since we are moving we're moving this to this pointer. So we're moving whatever the content of AX is to the location of SI, which is this location. We're trying to move this to the SI, right? Okay, and we know that each memory segment, each of this block is only 16-bit long, but we know AX is a 32-bit long register. This means the whole content of AX cannot be saved in one segment. So we have to divide the segments into two and separate memory blocks. So this means when we're trying to save AX to this block, the so when we're trying to save AX to at this position, the most significant bit, or AX, or this, will get saved on this location, and this lower bit will get saved on this location because the memory grows upwards. So this means the most significant byte will be copied at this address. So our answer will be 12222. I hope that makes sense. Okay, next question. So we have BX, we have data segment. Okay, we have BX, we have data segment. Then we know at this memory location we have 10H, at this memory location we have 20, and at this memory location the value of 30 is saved. Okay, what will be the hexadecimal value of CX after executing the following instruction? Okay, before we get into the instruction, let's draw the data segment so it makes much sense. What are we actually dealing with? So let's say this is the data segment. It has memory blocks. Okay, and we know that this data segment is this one, right? Okay, cool. Now we know that at this location 11.11100, we have let's just say this is 1100F is this. So this means the next memory location will be, so to find the next memory location, we're just going to do this. F plus 1. F plus 1 becomes 0. We'll carry 1, 1, 0, 1, 1. So next memory location will be this. So this means 1, 1, 0, 1, 0 is this. And the next one will be 1, 1, 0, 1, 1 will be this. All right. We know at this location, we have a value of 10. At this memory location, we have a value of 20. And at this one, we have a value of 30. Makes sense. That's all we know, right? That's all what's given to us. Cool. Now let's look at the instruction. So that's the instruction that we're dealing with. So we are moving BX plus 10, whatever, to CX. Okay. So first of all, we know CX is a 32-bit register, right? That's CX is 32 bits. And each of these memory location are 16-bit long. This means, what does this tells us? That if we are trying to save something from this data segment to CX, we can save one memory location. Let's say this is memory location 1, and this is memory location 2. So the size of memory location 1 is 16 bits, size of memory location 2 is 16 bits. CX is capable of storing 32 bits in itself. So this means if we are trying to save 1 to CX, we'll fill the lower half with 1, but we'll have 16 bits more to go. And we can fill that with 2. It'll fill it itself with 2. It's just like given, like how this works. So if you're trying to save something which to CX, but it can save more data, like it'll look into the next memory block to save all of the data together. But that's beyond the question. But we'll get back to it right now. Okay, but first of all, let's deal with BX plus 10. So we know BX is 1,000. 1,000 what? 1,000 hexadecimal, but where? So BX has some data, and we don't know what data is it. So, and we know data are always stored in data segments. So this means to find where exactly the offset of BX is, we need to do this: DS, the data segment address, plus BX, the offset of where the BX is pointing at. Maybe the BX is pointing at here, maybe here, maybe here. We don't know. We just know that BX is this. And plus 10, because this, I got it from here. Okay, so the data segment is 10000, right? BX is 1000, and then we are adding additional 10. So which means 0, 1, 0, 1, 1. So this means this whole thing, BX plus 10, is pointing at this memory location, 11010. So this means this whole thing is pointing at this memory location, this data segment. So this, okay, so we are trying to move to we're trying to move 20 this, we're trying to move whatever stored in this location to CX. Okay, so this means CX will have a value of 20, right? We're moving whatever the content of BX plus 10, which is this memory location, to CX, which is 20. But that's the thing, CX is a 16-bit register, and we only moved CX is a 32-bit register, and we only moved lower 16 bits. And there is still space for more 16 bits to be placed somewhere. So this means, since let's do this. So each bit is each blank is an 8-bit. So this represents CX. Okay. So we fill the lower, because the BX plus 10 is pointing at this location, and this location is pointing to the value of 20. This means the lower bit will be filled with 20. But what about these 2 bits? These 2 8 bits. What will happen to them? They will get replaced by the value, they'll get filled by the value right above this memory location, which is this. And at this memory location, we have the value of 30. So this means 30. So this means at the end of this instruction, CX will have a value of 3020. I hope that makes sense. Okay, on to the last problem. So in this case, in this problem, we have stack segment, a base pointer, a source index, and that's it, right? And we have to find the physical address of the memory location in which AL will be copied after executing the following instruction, and that's the instruction. Cool. So, okay, so we are saving the value somewhere on the stack. We're not dealing. Okay, so this means let's draw a stack. Let's say this is the stack, and this is the stack we're pointing at. Cool. Now, you know what? I don't think we need a stack in this case. We can just solve it without drawing a stack. That's one pretty simple. Okay, so we're moving the offset of BPSI 10H. So our CPUs are capable of adding these instructions together. Like it knows what it means. What it means is we're the address of base pointer plus the address of source index will give us the actual value, that actual location where we want to save the value of AL. Actually I draw the stack segment to make it easier. Let's say this is the stack segment. All right. And let's say base pointer is 3, stack segment is 2. Let's just assume. Okay. So let's say 1, 2, 3, 4, 5, and 6, and 7. Let's just assume. And we're adding another 1 value to it. Okay. So what our computer will do, it knows that we're adding, it will, after it see this move BP SI 10H, it'll know what we are meaning. And what we mean is the base pointer is pointing at 3. Then basically what does, okay, scratch everything. Basically what, let's say BP is 3, 2, and this is 1. So what does this instruction do? It just basically adds them all together to find where in reality do we want to put the data at. In this case, it'll be 6. So this whole thing combined will give us 6. So this means it'll put AL to the 6th place of the memory, if that makes sense. That's how it works. But that's the basic idea how this instruction works. But let's try it. So we have a base pointer, a source index, and then value. Okay, so the base pointer is in the stack segment. So to find the actual address where we want to save this value at, we can do this: stack segment plus base pointer plus source index plus the whatever the value is, 10H in this case. So this is 1, 0, 0, 0, and we add a 0 because it's a segment. Then the base pointer, which is 1000. Then the source index, which is 100, and then another value of 10. We'll add them all together: 0, 1, 1, 1, 1. So this will be the location in the stack segment where we want to save the value of AL. And in this case, it's just asking for the physical address. So we can just write 1, 1, 1, 1, 0. That'll be our answer. I hope this all makes sense. But if it doesn't, feel free to reach out. Thank you.